Okay, so the next section of this section will deal with us identifying even and odd functions. Now, the one I just showed you was not a function because it did not pass the vertical line test. So any graph that would be symmetric about the x-axis, maybe it's like a little sidewards opening parabola like that, which would be symmetric about the x-axis, it's not a function, right? It fails the vertical line test. So now, if we're talking about a function, x-axis symmetry is off the table. We're really only going to look at, for functions, two types of symmetry, and that is symmetry about the y-axis and symmetry about the origin. Okay? Those types of graphs could pass the vertical line test, therefore be called functions. All right? Now, there are actual technical tests here to see if we have an even function or an odd function. Now, what does it mean for a function to be an even function? Well, an even function is nothing more than a function that is symmetric about the y-axis. You remember that absolute value graph? That would be called an even function. All right? Now, here is our test that we will apply to see if a function is an even function. This is read, if the function evaluated at a negative x is the same thing as f of x. You know what this is saying? Replace x with a negative x, simplify, and see if you had the same thing as what you started with. Okay? So there's the test for an even function. All right? Now, an odd function, we're going to call all functions that are symmetric about the origin an odd function. There is a test to see if something is an odd function. Okay, and it says right here, if your function evaluated at a negative x is equal to the opposite of your function, then you will have an odd function and you're going to see symmetry about the origin. And basically what you're doing here is you're replacing x with a negative x and fancy pants y with a negative y. That is our test to see if something is symmetric about the origin. Okay? Now, on example 3, we are given some graphs of functions. And it says, and all these are functions, you can apply the vertical line test to ensure that they are functions. So now let's see if the function is an even function, aka symmetric about the y-axis, an odd function, aka symmetric about the origin, or maybe it doesn't display any of those symmetries, or either of those symmetries, I should say. Okay? Now, on number 22, okay, this thing would be symmetric about the origin, because for all of the xy points, okay, if we have an xy point on our graph, then we also must have a negative x, negative y point on our graph. Let me give you a couple of examples of where that will occur on number 22. Look at this point right here. This is a pretty easy one to pick out because it crosses at a nice spot. The point 4, 1. If this thing is symmetric about the origin, then negative 4, negative 1 must also be on our graph, and it is. Okay? We replaced x with a negative x and y with a negative y is what you can consider there. Okay? Here's another example of why this is symmetric about the origin. Let's see like this point. Let's pretend like it goes right here. Okay, at negative 2, 2. Negative 2, 2. We're going to change both of those signs, and the point positive 2, negative 2, positive 2, negative 2 should also be on our graph. Okay, so that means that this thing is symmetric about the origin, which we call that, let me scroll a little bit. Okay, I'll scroll a lot bit and then scroll back up. We call symmetry about the origin an odd function. Okay? This is an odd function. Now, look at number 24, and I don't know about you, but to me it seems like we've got a little reflectional symmetry about the y-axis right here. I think this thing might be an even function. Well, to determine that for sure, we're going to say if I have an xy ordered pair here, such as 1, 2, if this is symmetric about the y-axis, then -1, 2 must also be on my graph, and it is. Okay, there's an example of why this thing is an even function, symmetric about the y-axis. Okay, here's another example right here. Let's see, -2, -2. All right, let's pretend like that's a point on our graph. Then also 2, -2 must be on our graph as well. Okay, so -2, -2, as well as 2, -2. The x values are changed, but the y values stay the same. That's why this thing is symmetric about the y-axis, and we call this an even function. All right, that's even. Now, this function over here, I know it's not symmetric about the y-axis. You see that if we would fold our paper, one part of the graph does not lie on top of the other part of the graph, okay? There's not that reflectional symmetry about the y-axis. Let's see maybe if this thing is symmetric about the origin, okay? Let's see. Remember how we saw if it was symmetric about the origin over here? Let me get a point on this graph. I'm trying to eyeball kind of a nice one. Okay, let's do this one right down here. Okay, if this thing is symmetric about the origin and it contains the point 3, -3, okay, then if it's symmetric about the origin, we must have changed both of those signs, -3, +3 on our graph. And -3, +3 is up here, and that's not on our graph. So this thing is also not symmetric about the origin. We say that this one has none of those symmetries, no symmetry, and so we say that this is neither even nor odd. Okay.